Cool. So yeah, hey, I'm gonna talk about compilers, as Panu put it, but it's not actually a scary topic, right? I'm here so that you can write your own compiler in Clojure, right? And it's okay, right? I'm gonna say first the conclusions. It's totally fine. It's great, right? So the backstory is that I made a small compiler in Clojure, and it is a Dhall compiler. Yes, like you can bother me on Twitter at these handles and comments, suggestions, complaints, rants, like hate letters. I don't know, like anything. Yes. So I promised myself that I would not talk about food, but here we are. So if you were at Clojure, I did a talk about doing DevOps with Dhall, and yeah, Dhall is this great dish. But it is also a language, and in there I did talk about, okay, let's use Dhall to make something cool and like actually usable and like useful in life. And the meta talk about that would be, okay, let's talk about Dhall itself. And the meta talk would be, okay, let's talk about a Dhall compiler. So like going from here to here, it's kind of a string. So today I'll try to be here on the border, right? To talk about Dhall, we should have a Dhall meetup or something. I don't know, that would be cool. But yeah, let's talk about a Dhall compiler in Clojure. So this is basically the story of me learning about making a compiler is actually not a traumatic experience or a scary thing, or like here be dragons. No, it's okay. So who knows about Dhall? That's cool. Who used Dhall ever, even just to try it out? Okay, so I guess we'll need a small tutorial or a small introduction or something. So Dhall is a functional and non-Turing complete and strongly typed language. And you can think of Dhall as being like basically JSON. It looks like JSON, right? It has like records and lists and numbers and strings and all the things that JSON has. Plus it has types. So if you want to define the type of your data structure, you can, and you can do that in Dhall itself. You can import things. So like when you have JSON, you have a JSON file, and that's it. You cannot import more JSON from there, right? That's scary. Like, but you know you can. Like you can import stuff from the internet, from local, and it's totally safe. And we'll see later why. And you have functions in Dhall to manipulate Dhall itself, which makes it pretty powerful. But still, it is not Turing complete. So it's a really cool thing, right? And yeah, right? So what is a programming language even, right? It's kind of a philosophical question. Like, I don't know. Like, okay, is it a thing you can write code in? But like, also data is a programming. Like, you can, like, JSON is a programming language, maybe. But so it's kind of a continuum, right? But there's a line I would like to put here, which is the Turing completeness border. So over here, it's like really dangerous, right? But really powerful. You can write operating systems in it, like whoa. And on that side of the line, there's like data. You can like it's pretty secure and safe to send around, right? Just don't put your passwords there, and you'll be fine. But Dhall stays just here in this line. It's really hard to be like just here on the line. Like it's really easy to go over, right? But in this case, non-Turing completeness is a feature. And you might be asking, like, okay, so you did this compiler for Dhall in Clojure, but okay, what is this useful for? Okay, like we wanted to have fun, right? But like, is this thing actually usable and useful? Yes. And like, you know, the common complaint is like, okay, whatever, I have to learn another language to do things. Like, let me have my JSON and YAML and HCL and whatever data language. Like, it's okay to pick up another small language, right? But this is actually revolutionary, right? Because, well, if you have a JSON configuration, how do you type your JSON? Like, if you change your JSON, is your application gonna complain about it? Most likely not. Maybe. Like, I think you do the things properly, but sometimes it happens that, like, yeah. But in Dhall, you can say that your configuration has a precise type. Or you can use Dhall for templating things, like, let's say, I don't know, you use Mustache or Jinja or whatever templating language. You can use Dhall, and it's more safe than Jinja because Jinja is Turing complete, right? But Dhall is not, and but it's still like it's same but powerful. And then a really useful feature is that since it's not Turing complete, you can send code on the wire in a safe way, and it is efficient to do so because in the standard there is defined a binary encoding for it, so like the packets are really small. So Dhall is actually useful. So I would like to try this Dhall thing. Where can I do it? You can go to dhall-lang.org and try it. There is like a interactive demo on it, so yes, Dhall is running in the browser in JavaScript. Or you can install the Dhall CLI. If you search Dhall on GitHub, you will find how to install the thing. And today I'm going to talk about the fact that you can like grab just the jar from Clojure and run a Dhall compiler in your Clojure program. So yeah, this is how like dhall-lang.org looks like. Is there designers in the room? No, that's cool. So I can have more remote colors on the slides. So yes, you can try like typing in here, and you will see the output in here, and you can render in different formats. Like here's the Dhall. Here's the YAML rendering, but you can render in JSON, or you can see the normal Dhall output, or you can see the type of your program that you typed in there. And you can try different examples in here, and there's very many links and a pitch if you want to sell it to your coworkers, a lot of things. So it's cool. So I'm running a poll now. Would you like a Dhall tutorial now or in 5 minutes? In 5 minutes, right. So I can talk about why am I doing this compiler thing, right? So the thing is, when you have a JSON configuration in your program, you need your language to understand JSON, so you can decode the JSON in native data structures for your program. And when you have a YAML configuration, you need your programming language to understand YAML, so you can have the configuration in native data structures. You see where I'm going, right? So Dhall, if you want to have a Dhall configuration in your program, you need to have some library that reads that Dhall inside your program, right? So Dhall shines when it's natively integrated into languages. But the problem is that it's a young language. I mean, it's from last year, right? So give it time. But there is no integrations yet, except Haskell. Well, now also the Clojure integration. So yes, I was like, okay, let's just make an integration with Clojure. How hard can it be? It turns out it's okay. So there's some good news, right? There's a language standard, so you can just read the standard and follow it and implement the thing, and it works. It's cool. And actually, it is not common for languages to have a standard. Like I don't know, Python. It's a really I think it's the biggest example of languages that don't have a standard, in which the standard is the compiler. There is reasons for this, and I'll tell them later. The other great news is that the language is tiny, so implementing it looked easy. It's okay, right? Like it pretty much holds. There is of course the hard parts, but it's fine. So yeah, so it took me 6 months from thinking, okay, that's cool, let's do this, to actually get the thing ready, which is not that long time, given that you don't work on it full time, right? So you can grab it here on GitHub. And yes, what I would say, like, my main point of today is that making a compiler in Clojure is fun, it's easy, and it's useful because, well, for all of these reasons. It is kind of a restricted problem, so if you want to, like, it is interesting and fun, and it's not that messy, right? You have this thing, okay, I have source here, and I want to execute this source here. That's it. Like, and then you code the whole thing. You don't have the external world interacting with you, and so on and so on. So it's kind of a closed universe problem, which makes it a nice problem to solve with programming. And it's a great example where scene design is paramount. Like when you're making a compiler, sorry.
Just noting that it's kind of a common truth that the sweet spot of functional languages is doing compilers.
I mean, I think like, yeah. I agree.
So,
yes.
So it probably applies here too.
Yeah. Yeah, because like you don't have side effects, right? Like you have input and then you put it out.
transformation.
That's it, yes. So that's the reason, I guess. Yes, and you need to have the same design because well, you're executing code, so you don't want the thing to get messy, otherwise you lose track of what's going on. It also, I think, the best place to apply TDD. Like you have your example of the test here, and you know that you have to like make it equal to the output. And, like it's just so good. Like you have the tests, and then you develop the thing. It's straightforward. Also, Clojure makes it really nice to manipulate data structures for a whole lot of reasons. Yeah, I don't know. I accept the input on this, on why it's so nice. I'm still not sure, but it's really nice. And also making a compiler helps you understand how the tools work, like how the Clojure compiler works, and like the various tools that transform source and so on. Like it is really that didactical experience. Oh yeah, sorry, I almost forgot this. Sorry, Rich. So what's a compiler? I cannot have a Clojure talk without the vocabulary thing. All right, so the first definition is like sounds kind of medieval, right? It's a person who produces a list or book by assembling information or written material. No, it's not that. I think this is the right definition, right? It's a program that converts instructions into machine code or lower level form so it can be read and executed by a computer. I think that the definition by now is a bit broader. Like it's generically like you take source string and you get executable. But like nowadays, because JavaScript, I guess, we have also transpilers. So you take source and you get other source, and we don't care about the execution. That's taken care of by other things. So we go from string to executable, and we can't do this in one shot, as like GCC realized in like I don't know the 90s. Compilers should be modular and make use of phases. And so through these different phases, you take your source and you change it into different representations, and very often there are different representations like between different phases. And I think this is one of the cases in which more types are good, where types are different intermediate representations of your data structure. I think this is kind of a general principle. I don't know. I'll think more about this. But anyways, basically all modern compilers have very many phases. This is, for example, the Clojure script compiler. This is a talk by Maria Dhall about the Clojure script compiler. And yeah, the Clojure script compiler takes the source, it reads that into some data structures, like, okay, there's a function application here, so on and so on. Then it does macro expansion, like, okay, there's a def hand here, I have to generate a whole lot more code, and so on. And then it does it emits the ASD after having analyzed it. Okay, is this ASD, is this data structure correct, and so on. So it gives back ASD if everything is fine, and then it emits JavaScript straight. And then this is like the Rust compiler. I don't know if this is like the current architecture. This is from 2016, but yeah, like you can see there's the Rust source, and then it goes through a bunch of phases. Like there's parsing, type checking, borrow checking, optimization, and then you have the machine code. And then, well, this is the best, you have the Haskell compiler, which is really many phases, and then like you have type checking, simplification, etc., and then you have machine code here in the bottom. And this is like how the Dhall compiler works. It's like divided in phases. And this is the most important slide, right? So you take the source, you parse it, and then you resolve all the imports, because the next phase is going to be the type check. So if you don't know what sits on the other side of the import, you cannot deduce its type, right? So you need to do this before type checking. So you get the import-free ASD after that. ASD is abstract syntax tree. So it's like data structures that represent the source in some way. So after the type checking, you know that you have valid ASD, so you're not trying to apply a function that takes a number to a text, right? If everything is fine, then you pass this to the normalize, which is the execution of the code. And then after that, you have the executed code, and you can generate Clojure code or whatever native languages. Does this make sense? Yes.
Yeah, but kind of from a compiler point of view, the normalization
You're right,
means
like
that everything gets applied there, and it's not really at least compiling to code in the Dhall sense.
So I think this is a philosophical question, right? We have to go back to this slide, right? So here you have like Turing complete languages in which you have the concept of running a thing. Like you start the program and then it does things, right? And you don't know if it stops or not. And here you have data, so you know that on this side you can normalize your data to a data structure. And the concept of normalization is kind of like, as in logic, like as in mathematics. So there's no concept of execution over time, because you always have a normal form, right? So, I don't know. I guess at this point we could say that JSON is mathematics, so I think we can stop here before being too
like I don't want to get stuck on this, but
yeah.
you could basically have a compiler for Dhall that translates Dhall into Clojure and calls eval. That's
I do it.
Compiler.
I do it after here. After here, you're sure that you can do it, because the execution semantics of Clojure are not the same as in Dhall. Yeah. I have to think about this actually. Maybe it works. But yeah, you're right. Like I think this is the actual compilation, and here is execution. Though I need to look more into this, because this comes straight from lambda calculus, in which you have alpha substitution and beta normalization, and it is the beta normalization. So I don't know. Let's get in touch about that later. Anyways, it's demo time. So I'm gonna show you some Dhall. Right. Can you see this?
Who can't?
Okay. How about now? Okay. Amazing. All right. So yes. So when you import the Dhall CLJ package, you get these two functions, which are the main API of the package. This input AST runs all the phases, and it gives you back the AST. So it's not Clojure. Well, it is Clojure data structures, as we'll see, but it's not Clojure native data structures. It's like the representation of the execution, and this input converts your thing to Clojure data structures. Yes, so let's see how it works. We can see the compiler phases later. So let's do a Dhall introduction in 30 seconds. All right, you can. I'm gonna make this a bit bigger. You can have like numbers, and you can add them up in Dhall, and right, we get back a 2, which makes sense. 1 plus 1 is 2. That's right. And we can take a look at the type of the expression. So here we take the expression, we parse it, and then we type check. And we're gonna get back the type of the expression, right? So this is like the sum of these numbers is natural, so this tells us that we have a natural type here. So that's cool. So Dhall has a list type. So here we have a list in Dhall, and then we read it into Clojure, and then we get back a vector in Clojure. And then we can do things like concatenate lists in Dhall with that hash operator. So here we concatenate two lists, and we get back a Clojure vector. So that's cool. Now there is a map type that is called record. So here we are inputting a map that has name and year key. This is text. I had to escape the what's the name of that thing? The quotes, yes. Yeah. Yes. So if we read that in Clojure, oh, well, yes. We get a record that has name, key, and year, and this is a text, and there's a number there. And we can ask for the type of this thing. So again, we parse, and then we type check the thing. And then we can see that we have a record type that contains the key's name that is a text type, and the year, well, I'm gonna make this slightly smaller, so we can look at it, yes. And then a key year that has a natural type, so type checking works. And then we can merge records as in Clojure, right? You have two records that have different keys or the same keys, and you can merge them together, and you get back a single record. Note that here, this is a Clojure map, so we're emitting the thing, and we're getting the Clojure translation of it. If I would use the input AST here, I would get back the AST of Dhall, which is, so well, it is a record literal that has the keys blah blah with values blah blah. So here the translations to Clojure that it's happening in the background, and we're actually running eval on the output of the thing.
But is it Clojure eval or Dhall eval? Probably Dhall eval, right?
So I have an example later in which I ran the.
Okay, sorry.
Okay, right, that's cool. Yes, unlike in Clojure, there is a maybe type and no strong feelings about it. Maybe it's okay. So when we run the the conversion to Clojure, we get back a number if there's a value in our optional, or if there's no value, we get back in it because it's idiomatic this way. Though if we ask for the AST of this thing, then we're going to have a sum, and that contains a natural literal, and in here we're going to have a non. Well, it's an application of non to the natural type, which if we ask the type for this, it's gonna be an optional natural. Let's do this actually. So we're gonna have non-natural, and then sorry.
Why is there a
right.
second arrow?
Yeah, that's wrong. It didn't it still worked. It's okay.
I mean,
Mystery of the
of
web.
course it works.
Yeah, I don't know. Why it's
Yeah.
let's see. All right, it's application of optional to. I'm not sure this is the right type. Maybe there's a bug. Well, anyways. Yes, there is also booleans in the language. So, and it's actually the only type on which we can run if-else things. So, like in the if test, you can only put a boolean in there. So, if we run this, then we get 42 because this evaluates in Dhall that true is true, and then it returns 42. So, note that the evaluation here is happening in Dhall, and then we're just converting the result to Clojure. In fact, if we run AST here, the result that the AST that we get is just the result already. And then there is other operations like or and so on. Then, like in Clojure, we can assign things to names, like with let. So we can say let something equal something in whatever. And here we use this name here to template this string because there is string interpolation. So we can have this funny syntax with a dollar and put a Dhall expression in there. And also Dhall strings support Unicode, so it's cool. So if we evaluate this, then the name will be substituted in the string. So it works, templating works. All right, so there is also functions in Dhall, right? So we can write a function this way with the backslash. Note that, again, here we have to escape the backslash because Clojure strings. So we can say function from n to n, which is a natural, and then we return n times 2. And this will evaluate to a Clojure function, actually. And we can actually run this in Clojure. So if we do input here of that same function, and note that we can also use Unicode symbols to do that. Then we can assign it to twice, and then we run twice, right? So if we do twice 4, we get 8. So we get the function from Dhall, and we run this function in Clojure. And in this way, you're getting the function into Clojure and running it in Clojure. But of course, you can run the function also in Dhall land, right? So here we have a function cube that takes n and multiplies it 3 times, and then applies cube to 42. So if we evaluate this, then we get like the cube of 42. Questions? Yes.
Can you show the AST of the last one?
Yes. What do you expect it to be?
A number.
A number? Other guesses?
Or It's a number type record with a number.
Oh, sorry for this. It's a number. So it's a natural. Because the execution happens in Clojure. Though if we happens in Dhall, sorry. If we what happens? If we run the AST of this one, then we're gonna get a lambda that takes n, and the type of the n is natural t, and the body is something. Oh. Make sense? Other questions? Okay, let's go. All right, so there's a more interesting program. Oh yes, there's also comments in Dhall, unlike in JSON, so this makes it already much superior to JSON. You can have long comments too. And in here, we're gonna take advantage of the safety features of Dhall. So if you have an import, let's say I want to import, all right, there is a standard library called Prelude. So it contains like useful stuff, so you can import stuff from Prelude. So if, let's say I want to import the list map, but I want to make sure that the list map doesn't change when if I run the program today or tomorrow or in 2 years. So I can put a hash of the file in there, and if the content of the file is ever going to change, Dhall is going to refuse to run my program. So this is safe. So we assign this to map. We import the prelude from local file, and we assign the cube function that we saw before, and then we apply the map. Sorry, we map the cube function over this list of numbers. This natural, this is the input type, and this is the output type. So if we run this program, this is going to evaluate in Dhall, and it's going to return us the list of the cubes of the numbers contained in this list. All right. So yes, now you're ready to code Dhall. It's it. Next, yes, we saw the list of phases that happen when you compile Dhall. Yes, first we have the parsing. So we're using instaparse to parse things. So here I'm going to show a really simple example, but actually I am low on time, so I can skip most of this. Should I? It's okay. I'm going to skip most of this. So you can parse things, right? And this is going to return a big tree of stuff. And it is not nice to look at, right? I mean, you're not going to look at unless you're developing the compiler. In that case, you should talk to me. But if you want to read this into AST, you run this parse, which is going to return the parse tree, and then you transform this parse tree into actual AST that we can manipulate and stuff. So if we read this one we parse it, and then we make AST out of it, then we get the natural return. Next, type checking. No, sorry. Import resolution. So here we are importing the map, right? From the prelude, and then we have to resolve the imports, right? Because if we just parse this, we're gonna have just the import as in the AST, but we want the actual content of the map. So we parse the thing, and then we resolve the import. And here we get back the AST of the map. So we have a lambda that contains an A that is a type, and that contains a lambda, and so on and so on. It's a big amount of AST. So that's the map. And then we can type check things. So you expect to have a type check error if your type is not right. So if we try to apply a function that takes a natural to a Boolean value, that's gonna fail, right? So let's say we try to type check that, and here we get the error, well, there's a type mismatch, so this doesn't work. So it's cool, our type checker is working. So in order to make the type check happy, we have to actually pass a natural in there, right? So we evaluate this source, then we type check that, and then we get back the type of this thing. Then once it's type checked, we can normalize the AST. So we parse that into AST, we type check that, and then we normalize it. And then, yes, we get the execution of this function applied to the 42, and then we get back the 42. It is basically what input AST does. And we can actually see the Clojure code that is generated by the emit, right? So if we do the same as above, but we also do emit, so if we have this function that returns so it takes an x and returns x plus 1, then we're going to get back a bunch of Clojure code that does the same. So here we have a function that takes an x and it applies plus to x plus 1. So that's it. Now, use case. So I said that we can safely throw code on the wire. So let's say I want to have this function, then I want to run it on another machine, and I want to encode it in binary and so on. So here we import the binary stuff, and then we can serialize the thing. So I read the thing into the AST, and then I encode it, right? And it is going to be a byte array. So if I ask for the type of this is a byte array. And then, well, we can look into the content with, like, we make it into a vector. And then you can send the bytes to another machine, like you throw it on a TCP connection, whatever. Once it's there, you can deserialize your thing and you can run it. So here you take the serialize, you decode it, then you emit the Clojure code, and then you run the Clojure eval. Right? So we have here the function, and we check that its type is actually a function. And then we can apply the function to a number. Recall that the function takes a natural and then returns a record, right? And it does a bunch of templating in there. So if we run the function, then we get back the result as it's returned by the function. That's cool. Yes. So I don't know. This probably was a lot of stuff. So takeaways. So to parse stuff, I used instaparse, and it's really cool, right? I think it's the main reason why it was really quick to get this thing started. So with instaparse, you write a grammar. Who's familiar with BNF format? A BNF format, like this kind of, okay, that's cool. So I'm not gonna explain them from scratch, but yeah, you can write that, like parsing rules. Okay, the S is going to be 0 or more AB, and what's an AB? AB is concatenation of A and B, and what's A? It's 1 or more A's, and so on and so on. So we can get a parser of this, like automatically generated, and then we apply the parser to string, and then we get the parse tree, like the huge parse tree that we saw some time ago. So this is really useful because you don't want to write these parsers from scratch. Like the Haskell implementation has the parser handwritten, and that's quite a bunch of code, and I didn't have to write that, right? It's a bit slower, of course, but that's okay. I mean, the grammar is like 700 lines, so I'll eventually get back to handwrite that parser. Also, an important thing is that in Clojure, like for this kind of project, maintainability needs super much attention. Like, since it's dynamically typed, it's hard to refactor. Like, if I change something in the AST, I have to propagate that back into all the phases, and if I change something in parsing, how's that going to change in normalization, and so on. You have to keep track of all of these things. Yeah, so for this reason, 100% test coverage is a must, otherwise, like, stuff is broken. Like, if you don't test it, then you can assume it's broken. And please do different kinds of tests. Like, most of the times, like, most of the tests here are, like, single-phase tests, so, sorry. So I have, like, you can check that parsing is successful, so you say, I'm going to parse this and I expect this, or I'm going to type check this and I expect this, and so on. So that's really useful. You cannot have more detailed tests because every phase is kind of monolithic, right? Like you have an expression and you type check that. Like, how do you do smaller tests? Also, property-based testing is like really nice because, for example, for serialization, deserialization, you have to make sure that when you serialize an expression to binary, you're gonna be able to deserialize it as well. But what are you gonna do? Type down all the expressions you want to test? No, you want the thing to generate them, right? So that's really useful. Also, end-to-end testing can never be enough. Like, you have a compiler, so people can type whatever things in your thing. Like, you can write whatever source, right? And for whatever source, your compiler cannot break. So the more end-to-end tests you write, the better. Also, having a language standard is really nice. For Dhall, we have the grammar, and then there is the logic rules for transformations, and then there is the informal specification, like the document that says you have to do this and this and this. And then there is a bunch of acceptance tests. So the tests are like supposed to test corner cases, right? So they say whatever it thinks, and your compiler has to return this. So in this case, TDD is really natural, and it's actually pleasurable. Like, do you like to write tests? Who likes to write tests? Only in some cases, right? Yeah, exactly. So, but here it's really pleasurable. Like, you put the test up, and then until it passes, you write code. And but yes, I have an insight here. Like, not all languages can or should have specs. It's actually a trade-off between like speed and correctness. Because if you don't have a standard, you can move quickly. Like, if you want to break things, you can. Like, there's no standard that you have to upgrade and version and so on and so on. But of course, the trade-off is that like your language might be less correct. Like, you have no one that points out, hey, that's broken, or no one that can take your standard and re-implement another version and realize that the whole design is flawed. So it's a trade-off. So.
By the way, 3 minutes.
No, I'm done. And also making a typed language is not that hard. Like, there's not special magic, right? Like, you take a parser, you make a grammar, you define your AST, like, okay, you're gonna have if and variables and numbers and so on, right? You want a type checker, pick a type system. You can read a bunch about type systems. This, I really recommend starting from this one. This like a small implementation of a dependently typed language, from the calculus. And yeah, then you just define how you're gonna execute your thing. But I mean, most of the times you're gonna start from lambda calculus anyways, so it's cool. So yeah, things to remember from today. So making a compiler in Clojure is nice. Dhall is really great. Language standards are awesome, and 100% test coverage is necessary. Well, for compilers at least. Like, if you can try to discuss this with your PM, maybe they don't agree. But yeah, and yes, stuff should be more maintainable and less spaghetti. Thank you. Questions?
I have many.
Yes.
I'm waiting for others.
I have one.
Yes.
There's also something there.
Timo, please.
That's right. So, okay, I'm gonna have a demo at the command line. Can you see this? All right. So if I can run the Dhall language, the Dhall CLI here, and I can, let's say, I'm gonna apply a function to, all right. This function takes a natural and returns a natural, whatever. And then I apply it to a true, right? This is supposed to be a type check error. Oh yeah, right, sorry. Well, this is pretty okay, right? Well, this is also a nice error, right? So can you figure out what's going on here? Maybe. Like, if you cannot, you can ask Dhall to explain you. And then it's gonna tell you in detail what's going on, right? Okay, explanation. Expressions cannot be referenced, previously introduced, blah, blah. And here's a bunch of examples, but then it gets into detail about your code. Some common reasons might be blah, blah, you accidentally blah, blah. Yeah, okay, there's a bunch of reasons. Another example, so let's say,
Change it to n.
yeah, this is right? Wrong type of function argument. It should be natural, but instead you have put a bool there. So in case this is not clear, you can ask Dhall to explain your thing. Okay, what's up? So there's the generic explanation, etc. But this is detailed. Like, you try to invoke the following function, blah, blah, which expects an argument, blah, blah, of the following argument, which has a different type or kind. I think this is pretty detailed. Like, I have always been able to figure out what's going on, like, from this. The only problem is that when you have gigantic records, like for our Kubernetes configuration, like Kubernetes types are huge. So for that, we had to like do a bunch of pull requests to the compiler to cut some output in a smart way and like display things nicely, and now it's manageable.
What about you, Kat?
Just a simple question. How many compilers have you created before?
So I did look into the Clojure script compiler, kind of in detail, but I wouldn't suggest that as a first compiler you look at. It's like really big, and kind of like messy, like the style is not consistent and so on. Then I tried to read the code of the Haskell Dhall compiler, and it is really nice. So yeah, I guess that's my first compiler. Yes?
Well, maybe the thing that I would like to ask the most was that did you find anything ready-made for this type checking? Because there's core logic, which you can use for something.
That's right.
Unification libraries maybe, but did you use anything like that?
All right, so that's a great question. So when do you need unification? When you want to have type inference. Because, well, you have a bunch of things, and then one has type. It could be.
It doesn't do type.
No, there's no type
Okay,
inference.
Yeah,
Right.
yeah.
So the type check. That's why the type check is straightforward to write. Like I can show a bunch of code from the type checker. Let's get.
And you have to tell map that it's mapping naturals to
That's why you
naturals.
have. Yeah, that's why you have to
okay,
specify
yeah.
types. Type check. Right. So I don't know. Let's say. For example, when you type check the variable, you check that the variable is in the context. So you do a lookup on the context. If it is, then you return it. If it's not, then you fail with unbound variable. Right? Or let's see. Like, well, Boolean. Like when you have you type check a type bool, then you return that it's a type because the type of bool itself is type. But when you check Boolean literal, so a true or false, then you just say that it's a Boolean, right? When you have n, then you type check that like both expressions are Booleans and so on and so on. So that's why it's straightforward. It's like top down.
Okay, we are a little bit over time.
It's okay.
Does anyone still want very much to ask a question? Okay, maybe. Thanks.